Welcome, physics students. We're going to talk about horizontal projectile motion. This is the motion of things falling off of stuff or shot sideways, completely sideways. And this problem, let's get right to it. We got a bridge in Colorado. Let's make that look like a Colorado. It rises 321 meters above the Arkansas River. So this distance here, this delta y, we're going to call it. We need to get used to seeing that. That's the change in the vertical distance. That delta y is 321 meters. Let me just make that a little bit neater. 321 meters. That's its vertical rise, it says. It says, suppose you kick a rock horizontally off the bridge, and the rock hits the water such that the magnitude of its horizontal displacement is 45 meters. Okay, what all that means is if you are standing up here, okay, and you kick a rock off of this thing, now it's going to make that parabola-looking quadratic equation path, and it splashes into the water here. Woo! Okay, and let's say that its magnitude of the horizontal displacement is 45 meters. So this distance here, right there, is 45 meters. You want to know the speed in which this rock was kicked. So we need to know the velocity of the rock to make this happen based on how this was, because if we shorten this distance, I guarantee you it won't splash as far out away from the bridge. So the height is a factor in this. Well, when you're doing problems like this, you're going to have to find the time it takes for something to basically fall as if you just straight dropped it straight down. That's going to take the same distance if you just drop it as you do to kick it off. Okay, so the time period doesn't matter. If you drop something or throw something straight out or kick something off like this, it's going to hit the ground at the same time. So how do we do that? Well, there's a nifty formula that usually looks like this. H equals 1/2 gt squared. And this is the height. We could replace this. We could say that equals delta y, because delta y is the same thing. So if we plug in what we do know and solve this, we can figure out what the time is. So what I do know is the height, or the delta y, is 321 meters. So 321 equals half of gravity, which is negative 9.81 meters per second, times t squared. Okay, I'm going to pause the video, and I want you to solve for t. I'll be right back. Here. All right, so after you do this math, this is going to work out to t being about 8.1 seconds. Now think about that, will you? Something falling for 8.1 seconds. That's a long time, and usually in problems, nothing ever falls for 8 seconds. But this thing is about 3 Eiffel Towers or so high. So it would take only 8 seconds. Think about that. Unbelievable. But now, this is just the time. We need to figure out, and this is the important part of this, how far, or how the speed in which it takes something to go 45 meters in 8.1 seconds. So let's think about the guy standing here for just a second here. Here he is, and he's on some flat ground, and let's say he was just on the road or something, and he kicks a rock, and it goes out through here like that. Well, how far would it take it if it could go 45 meters? Well, we know that velocity is just the displacement over time, or distance over time, right? Well, how far does it go? Well, it's going to go 45 meters. I know it's falling through the air, but it really is the same kind of problem as if it was just rolling out through here like this. So how far would it take to go 45 meters? Well, that would just be 45 meters divided by 8.1 seconds. So let's hit that on a calculator. 45 divided by 8.1 is about 5.5-ish seconds, or meters per second. So this would be about 5.6 I got meters per second. This is the initial speed of the rock getting kicked. So if you kick this harder, it would fall farther out here maybe and splash out here. But to make it go 45 meters after a cliff or a fall off a bridge of 321 meters, it would take a kick speed of 5.6 meters per second to make that happen. And this is basically horizontal projectile motion. You can switch this problem around and say, well, if you kicked the rock at 5.6 meters per second, how far does it go out and hit the water? You could do an infinite amount of things with this scenario of just this guy kicking a rock off the bridge. And I want you to think about this. There'll be lots of problems. Have a good one.